Let's do some math. All right, so I'm going to do a series of videos on probability, and these videos are really geared towards high school geometry. I want to really just kind of talk about real quick about the difference between experimental probability and theoretical probability. Theoretical probability is just we're calculating numbers. We're not actually doing any type of experiment, or we're not taking any samples or polls and crunching numbers off of that data. We're just looking at just the raw numbers of it. Experimental probabilities, when we actually do the experiment and then we calculate the probability based off of the experiment. Now, in statistics, we have a thing called the law of large numbers. And what that's really going to tell us is that the more experiments that we do, the closer our experimental probability is going to become to our theoretical probability. Now, for a large time, like the magic number I've always heard or I've read that it's about around 30. So we're going to do some things in my class where we're going to have some where we have trials less than 30 and some with more than trials of 30 to see how this actually works out. And so you guys can actually see if the experimental and theoretical probability at some point actually becomes really close. Okay, so the first problem I'm going to do is I've got a bag. Within this bag, I have just simply 10 marbles. And this is a very classic type of problem that you're going to find in probability classes. I'm going to say, like, you know, there's 10 marbles in a bag. What's the chance? What's the probability of me pulling out a white marble, put it back in, and then pull another white marble out? What's the probability of that? Or what's the probability of me pulling out a cat eye marble first, and then put it back in, and then pull another cat eye marble out? Or any other type of combination like that. So to be able to do this, first and foremost, we have to know how many total marbles we have. In this case, I have 10 marbles. We have to know the different types of marbles. So I have a cat eye marble, which is an eye, which is kind of clear with a little cat eye in it, and then a solid white marble. So let's do the theoretical probability, and then I'm just going to pull out like 5 or 6, maybe 10, and actually see how the experimental probability compares to our theoretical probability. All right, so I'm going to do this with replacement, and what that means is when I pull one marble out after I record what happens, I put the marble back in and I start all over again. So we're going to do this with replacement. All right, so I know that I have 10 marbles, and 3 of them are white marbles, and 7 of them are cat eye marbles. I think we abbreviate. I think we put a hyphen in cat eye. All right, so really pretty straightforward. The chances of me pulling one out right off the bat is I'm going to take my number that I'm looking for and divide it by my total. So 3 for a 3 to pull out a white marble, I have a 3 in 10 chance of actually pulling it out. To pull out a cat eye marble, I have 7 out of a 10 chance, because there's 10 marbles, there's 7 cat eyes. 10 marbles, 3 white marbles. So the way we actually do this is I'm going to actually show you to use a tree diagram. We're not going to do these real large problems. I'll leave that for college for you. All right, so I'm going to go ahead and show you how to do this with a tree diagram. It's probably the easiest way in high school for you guys to understand. So when I pull out a marble, I have 2 options. There's 2 outcomes. An outcome could be I get a white marble. The other outcome could be I get a cat eye marble. So I'm going to start here, and I'm going to just draw kind of like a little branch, like branches of a tree. This is where I'm starting, and now I'm going to be able to pull out a white marble or a cat eye marble. Well, my white marble, the probability of getting that is 3 out of 10. My cat marble, the probability is 7 out of 10. Then I'm going to put that marble back into the bag. And then I'm going to repeat the process. So now I have 2 more legs coming out because I want to repeat the exact same thing. I want to repeat it. So I could get a white marble, I could get a cat eye marble, I could get a white marble and a cat eye marble. The probabilities stay the same. For the whites, 3 out of 10. For the cat eye, it is 7 out of 10. For the white here, it is 3 out of 10. And for my cat eye here, it's 7 out of 10. So to actually calculate these different probabilities, all we do is we multiply the branches. So say I want to know the probability of drawing a white marble after I drew a white marble. So white, white. 2 whites back to back. So I'm going to go white here and then white here. So this is 3 out of 10 times 3 out of 10. 3 out of 10 times 3 out of 10, which gives me 9 out of 100, which is going to be 9% of the time. So my expected outcome on this is if I did this experimentally 100 times, I should get 9 times where I pull a white marble out, put it back in, and then pull another white marble out. So that's for white, white. We're going to do this for each of the other ones. So what's the probability of me pulling a cat eye marble out after I have a white eye, after a white marble? So I'm going to multiply the branches. So I have, let's do white and then cat eye. So this is going to be 3 out of 10 times 7 out of 10, which gives me 21 out of 100, which is just simply 21% of the time. So if I pull out a white marble, put it back in, pull out a cat eye, it's going to happen 21 times out of 100, 21% of the time. That's what the theory says. And if we kind of go from here, cat eye and the white marble, this notation is probability of getting a white marble after you pull a cat eye. That's actually also going to be 21% of the time. It's really the same math as here. And the probability of a cat eye and a cat eye. So probability of pulling a cat eye after a cat eye. This is going to be 7 out of 10 times 7 out of 10, which is going to give me 49 out of 100, which then it becomes 49%. So this branch right here, we're going to say is 49% of the time. This branch here, 21% of the time. This one right here, 21% of the time. And this one here, 9% of the time. All right, so in theory, if you've done everything right, it's going to add up to be 100%, or if we do these decimals, it's going to add up to 1. Well, indeed, 21, well, let's do 9, and 21 gives me 30, plus 49 gives me 79, plus 21 gives me 100%. So I have every possible outcome figured out. So these are my theoretical probabilities. I didn't do any experiment with them. I just basically drew out the tree diagram, the chances of me actually pulling it out. Now let's do an experiment. So I'm actually going to pull it out 10 times. So my expected outcome out of 10 times is I should get cat eyes twice about half the time. I should get a cat eye then a white about 21% of the time. So if I'm doing 10, about 2 times, a white and then a cat eye about 2 times, and a white, I'd be lucky to get 1, but it should be close to doing 1. So what I'm going to do is let's just do the experiment. All right, so now I've done 10 trials. So let's actually calculate my experimental probability because I know my theoretical probability. All right, so let's look. So out of 10 tries, how many times did I get cat eye, cat eye? 1, 2, 3, 4, 5. So cat eye, so my probability of cat eye, I got 5 out of 10, which is 50%. That's pretty good considering my experimental probability is 49%. Okay, so what is the probability of getting a cat eye after I drew a white? Probability of cat eye after I drew a white. So let's see. I drew a white here and a white, so I didn't get it there. I drew a white here, then a white and a cat eye. So 1. So I'm looking for WC, white and then a cat eye. I got 2. 2 out of 10. 2 out of 10, which gives me 20%. Not bad. Chance of that's 21%, so not terribly bad. What is the probability of drawing a white after drawing a cat eye? So let's see, cat eye, white, 1. And I just have 1 of those. So I have 1 out of 10, which is 10%. And then last but not least, white, white. So the probability of white after I draw a white. So let's see, 1, 2. I got 2 out of 10, which is 20%. Now, what's nice about this is that here's pretty close, here's pretty close. Here's where my variance is. If I would have drawn a cat eye then a white, I would have been spot on to my theoretical. But the more that we would do this experiment, the closer we're going to get to our experimental probabilities. Now, what's really... Hi, I'm Mr. Buzzard, And I'm making these videos as supplemental instruction for my students. If you found these videos actually informative or they answer the question you're looking for, make sure you hit the like button, and then don't forget to subscribe and then click the bell to receive notifications for future instructional math videos.